Alright, Chapter 3, Test Corrections. Again, pause and rewind the video as needed. Problem 1, Bank A. It says we have a yearly compound interest. So in this case, we have the 5.1%. We have to add it to 100% because it is going to make our money grow. We're going to divide that by 100. And if we do that, you can see that it is going to equal 1.051. That's our multiplier. In which case, the equation is going to be y is equal to 1000 times 1.051 to the x power. And remember, x is the number of years. Okay. Bank B. Bank B, we have a compound interest. This time we're going to compound it quarterly. So in this case, we have to take the 5% divided by 4. That's going to equal 1.25%. And again, that's going to make our money grow. So we're going to add on 100%, divide it by 100. In this case, our multiplier is 1.0125. So using our geometric sequence again, we'll have y is equal to 1000 times 1.0125 to the x power. But this time, x is the number of quarters. Okay, so again, it's 4 times a year, so the number of quarters. So we take our number of years and we multiply it by 4. Bank C is completely different. This is a simple interest. We haven't done simple interest in a while. You have to look back at your notes from the beginning of the chapter. Remember, simple interest is arithmetic, which is mx plus b. The m is the amount of money that the bank is going to add on every year. In this case, to figure out how much money the bank is going to add on, we're going to do 6%, change that into a decimal, and then we're going to multiply it by 1,000. So 6% of 1,000 is $60, and they're going to give us $60 each year. So that's our slope. In that case, y is equal to 60, our slope, times x plus 1,000, which is our initial value. We're supposed to figure out how much each of these banks are after 10 years. Well, for Bank A, we just plug in 10 for x, come up with $1,644.47. Bank B, we are going to put in, now notice here that we're going to put in 40 because we have to take 10 years. We have to multiply it by 4 because it's 4 times a year, in which case we're going to come up with $1,643.62. Again, 10 years times 4 to come up with 40. Bank C is at simple interest, so we do the slope, 60 times the number of years, which is 10, plus 1,000, you come up with 1,600, and you can see that the best bank to invest your money in is Bank A, 5.1% compounded yearly. Alright, problem number 5. We're supposed to work with this new bank called Bank D. It gives us the equation to the bank, and it looks like we have 2x. The 2x means we're going to get compounded 2 times a year. We know it's compounded because we're using that geometric equation. So in this case, we're just going to figure out our x value. We're going to figure out our y value. X is the number of years. So we're going to plug in 10 for the x value, and I think the people that made mistakes in my class, they put in their calculator as 1,000 times 1.0265 to the second power, and then they multiplied it by 10. So you have to make sure that 2 times 10 is in parentheses, or if it was me doing it, I would want to make sure that I don't make that mistake, so I just do 2 times 10 in my head and put in 20 into the calculator, $1,687.25. Easy problem as long as you get in your calculator the correct way. Alright, problem number 6. We're supposed to figure out what the yearly rate is. So in this case, if I take my multiplier and change it into a percent, I come up with 102.65%. Now knowing that 100% of my investment is included in that percent, I can tell that my investment is going to grow or increase by 2.65%. Alright, so again, I got to look back at my equation, which is y is equal to 1,000 times 1.0265 to the 2x power. And I realize here that my 2x, again, it means that it's being compounded semi-annually, or 2 times a year. So therefore, I'm getting 2.65% 2 times a year. So if I multiply it by 2, my annual interest rate is going to be 5.3%. Okay, and that's what the question asked for. Moving on to problem number 7. Alright, so in this case we have a decreasing percent. It is depreciating at 18%. So if I do 100% minus the 18%, I'm going to come up with 82%. Change that into a decimal, come up with 0.82. Just plug that into our geometric sequence. We come up with 100 times 0.82 to the x power. And again, if I want to figure out how much is left in 24 hours, I just plug 24 in for the x value. Come up with 0.854 grams. Problem number 8, simplifying problem. I'm going to do this 2 ways. I'm going to do it using the shortcut. So I'm going to distribute the 4th power to each of these items. So I have 3 to the 4th power. And then remember, when I have a power of a power, I multiply. So 3 times 4 is 12. So I have x to the 12th power. Then I have y to the 4th. So as I am writing here, 3 to the 4th power is 81. X to the 12th, y to the 4th. Now if you're not familiar with the shortcuts, you can write it out the longhand way, where I have 4 sets of 3x cubed y. In this case, 3 times 3 times 3 times 3 is 81. I have 12 x's, so that's x to the 12th power, and I have 4 y's, y to the 4th. So you can see both answers here match up, so you get the same answer no matter which way you do it. Next problem is not all really complicated. We do not have any negative exponents, which makes this problem a lot easier than it could be. Again, I can do this the long way, or I can use my shortcuts. So when I draw this out, I have 6x to the 3rd power. So x times x times x. And then I have y, and then I have z to the 5th. At the bottom I have 10x, y to the 6th power, z to the 4th. Notice I got a little ahead of myself here. I started canceling out already. So x divided by x is 1, y divided by y is 1, z divided by z, z divided by z, z divided by z, and z divided by z. Then my last thing would be to reduce my numbers. I know that 2 goes into 6 3 times and 2 goes into 10 5 times. So it looks like my final solution here is going to be 3x squared z, that's what's left in my numerator, and 5y to the 5th in the denominator. Now I know in my class a number of people answered this as 0.6. So 0.6 x squared, z, all over y to the 5th. And I accepted that answer, but when you're writing a fraction, you should not have a decimal mixed within a fraction. So that still should be in fraction form, which is 3/5. Problem number 10. We have x to the 3/5 power, and remember from in this chapter we've learned that any base to a fractional exponent, the fraction is the power over the root. So in this case we have x to the 3rd power, and the bottom number is 5, so that's the 5th root. Problem number 11, we have the square root of x. Well, square root of x, we can just assume here that we have a 2 on the radical, because it is the square root, in which case we have x to the 1st power divided by the root, which happens to be 2, because it is the square root, so x to the 1/2 power. Problem number 12 we are on. We have x to the negative 4th power, and remember from this chapter that any negative exponent means we take the reciprocal of the base. So if I think about the base here, the base is x. Reciprocal of x is 1 all over x. So 1 all over x. And then I still have x to the 4th power. So 1 all over x to the 4th power. Which is also the same as, if I put this in here, 1 all over x. Parentheses to the 4th power. It means the same thing, because 1 to the 4th power is 1. Moving on to number 13 here, I have 1 all over the cubed root of x to the 2nd power, If I change the denominator to a fractional exponent without the radical, I'm going to have x to the second power third root. And then again, it said I want to write it as x, not 1 all over x. So I need to flip it to the other side of the fraction bar. So in that case, whenever I flip something to the other side of the fraction bar, I have a negative exponent. So it's going to be x to the negative 2/3 power. Number 14. I have the points 210 and 5 and 0.5625. I'm going to plug both of these into the y equals ab to the x power. Now there are other ways of doing this, such as making a table and finding your b value from there. I just find this method to be the most efficient way. So again, I use the higher x value, which in this case is 5. Plug that in first. I'm going to have 0.15625 equals ab to the fifth. Plug in the other equation as well, so I have 10 equals ab to the second. Again, to cancel out the a's, I have to do the opposite. Right now, it's a times b, so the opposite of multiplication is to divide. In which case, I have 0.015625. On the right-hand side, I'm going to have b to the third power. Take the cubed root of both sides, in which case b is equal to 0.25. Take that solution, plug it in. 10 is equal to a times 0.25 to the second power. Divide each side by 0.25 to the second power, so your a is going to equal 160. Plug that into the general equation of y equals ab to the x. So y is equal to 160 times 0.25 to the x power. Last question here is y equals x squared a function? Well, remember the definition of a function. A function has at most one output per each input. So if I were to draw this graph, oh yeah, we have that vertical line test. If I were to draw this graph, locator points at 0, 0, have a parabola. I'm going to use my vertical line test. So I'm going to take this vertical line, such as your pencil. I'm going to move it across the graph. Now, I don't know if this is actually going to work or not, but I'm moving it across the graph, and at no point is there any two outputs for any one output or any one input. So therefore, it is a function because there's only one output per input at most. And that concludes the test.